Welcome to Business Reporter's Sustainability, the Future of Business campaign. I'm Rachel Hicks. Year after year, our society produces 300 million metric tonnes of new plastic globally, according to a report by McKinsey & Company. 260 million metric tonnes of that plastic is disposed of, and only 31.2 million tonnes, a mere 12%, is recycled. The rest is landfilled, incinerated, or leaks into the environment. This is a colossal problem that hurts not only the environment, but also increasingly brands. Consumers expect a solution, and they expect it now. Their buying choices clearly signal an urgent need and an unprecedented opportunity for change. Today we're talking to Steve Crawford, Chief Technology and Sustainability Officer at Eastman, about a revolutionary technology that can massively expand the recycling of plastics over the coming years. Good morning, Steve.
Hey, good morning, Rachel.
Companies, especially consumer brands, have set recycling goals. Are those goals ambitious enough and achievable?
Yeah, so Rachel, the waste plastic issue, it's a colossal problem. And the brands are out in the lead, right? They have set really ambitious goals on recycled content. Many have talked about having recycled content of 50% by 2025, 2030. And they're putting a lot of pressure on the value chain and expecting material suppliers like us to actually deliver. The reality is, if you go across all of the claims that have been made across the value chain, add them up, it's just not feasible.
Okay, so that's really disappointing. What are the constraints on brands' recycling efforts?
Yeah, so really two constraints exist today. The first is there's not enough infrastructure on how to go and collect waste plastic, separate it, aggregate it, and get it back into the process. And that's been driven because of the fact that there's only one recycling technology that's been at scale today, and that is mechanical recycling. And while it's a great technology and should always be used, it cannot bring back materials or recycle materials that have colorants or additives or multiple polymers because it really does not efficiently go through their streams. The second issue is that with mechanical recycling, when you bring a polymer back through the process, after multiple cycles, the polymer actually degrades.
So how could industries overcome these limitations?
First, we have to be able to expand the technologies, the recycling technologies that we have access to today. Eastman believes in, I think the world believes in, the 3 R's. So we should reduce, reuse, and recycle. We should reduce plastic usage in every application that does not negatively impact the quality of life. And we should certainly design for reuse, right? You're seeing that now show up in home care items like shampoo, or like Eastman provides our Triton copolyester into hydration vessels that you see on college campuses, where the vessel can be used thousands and thousands of times, and it eliminates single-use plastic applications. But at the end of the day, plastic is an essential part of our ecosystem. It enables lightweighting in areas like automotive. It has great sterile type of properties in areas like medical. And even in packaging, it has the attributes of preservation for the materials that are inside the package. And so we're going to have to get recycling rates up. So we're going to have to expand the types of recycling technologies that we deploy. And that's why we believe in molecular recycling.
Okay, but what's molecular recycling?
Yeah, so opposed to mechanical recycling, where you recycle at a physical level, molecular recycling is what it sounds like it should be. you're actually recycling at a molecular level. So let me bring it to life. Most plastics originate from fossil feedstocks, shale gas or oil, where you bring the feedstock in and you break down chemically the materials into the basic building blocks. And then you put them back together again to get the polymer properties that you want. But those basic building blocks, carbon, oxygen, hydrogen, they actually exist in waste plastic. So why not go get the waste plastic, leave the fossil feedstock in the ground, break it down to the building blocks, and then build it back up? Well, most people don't understand in the heritage process, this step of fossil feedstock to building block is very energy intensive. So if you can design molecular recycling technologies at a lower energy footprint, you can actually use it to achieve your greenhouse gas goals. And the confusion in the industry is quite simple. All molecular recycling technologies are not the same, and many that we read about today are very much unoptimized from an energy perspective. But that does not set entitlement. The technologies that Eastman have today both deliver the replacement of fossil feedstock, but do it with advantaged greenhouse gas performance.
So if the solution is so clear-cut, why is molecular recycling not widely adopted yet?
Yeah, so I mean, up until now, the consumer perception did not drive the incentive for R&D investment or for capital investment. But that's all changed. The transparency around the fact that materials that get recycled or put into a recycle bin don't actually get recycled, and the understanding of how much plastic is now leaking into the environment, consumers are demanding it, right? And that's why you're seeing the brands respond. The big issue that we face today is that they're skeptics. Most skeptics think that this technology will actually, be bad for the environment, be bad for climate, and will actually interrupt the mechanical recycling stream. What they don't understand is if you use molecular recycling, materials that can't be recycled today, like the colored PET bottles that you see on the side of the road, or the really complex food packaging that can't go through mechanical recycling, molecular recycling can use that. It is extremely complementary.
What's Eastman's solution to these complex problems?
Yeah, so we have two technologies that we've already commercialized today. The first we call carbon renewal technology. And so that technology is extremely robust. We are actually using waste plastic that's colored bottles today, also using waste plastic that is the complex food packaging, and we're actually using carpet fiber that was from old carpet that would have been in landfill. And so we use it to make the basic building blocks to our cellulose diacetate product line. The process actually improves our greenhouse gas footprint by 20 to 50%. And we sell those products into durable applications. We sell them into ophthalmic frames, where we're commercial today, and also into our textiles industry. So you can actually go to our website, see our Naya Renew branded textiles. And we actually just announced a partnership with H&M to be launched in their Conscious collection. And so the second technology is our polyester renewal technology, where we actually focus on taking polyester PET that cannot be mechanically recycled back as a feedstock. And then we basically use that feedstock to produce our copolyester product family, including our Triton Renew. And we do it while we improve the greenhouse gas by 20 to 25%. And so this technology is at scale today, commercial. We're already selling into iconic brands like Nalgene and Camelback in hydration. And you probably just saw an announcement this last month where we've formed a partnership with Estee Lauder in cosmetics. The pull from the market is tremendous today, and the brands see that. So we can supply resin, and it will be more expensive, but only incremental. And the resin cost is actually a small part of the article cost. So for the brands, this is a very profitable situation because it's already been proven that the consumers will actually pay 20 to 25% premiums for recycled content into the articles they buy today.
So from your unique vantage point, how do you see the future of recycling, especially in light of the climate urgency we're facing?
Yeah, so from a vision perspective, Eastman as a company has a moral purpose, right, to improve the quality of life in a material way. And although our product portfolio is predominantly in durables, the climate issue, the circularity issue, the waste plastic issue is just too significant. We have to play our role. And so we're going to put a stake in the ground. We're going to continue to build out these capital assets. We plan to recycle as much as 250 million pounds of waste plastic by 2025 and as much as 500 million by 2030. And these technologies are very scalable. So we're going to be looking for partnerships, not just in the US, but on a global basis so we can enable global circularity where you basically use waste plastic, leave your fossil feedstock in the ground, and do it while you improve your greenhouse gas footprint overall.
Steve Crawford from Eastman, thank you very much for your insights into the future of recycling today.
Thank you, Rachel.